In this video, we're going to look at some application problems using logarithms. You might remember this formula from earlier in the section. It is for finding compound interest. The difference now is we're going to solve for something that is in an exponent position. And to do that and get the exponent to come down, you will take a logarithm of both sides. Let's plug in the things we know. And just a quick review, the A is the amount accumulated. The P is your principal. It's the amount you put in to begin with. R is your rate. Remember to switch it to a decimal, drop your percent, and go 2 places to the left. N is your number of compounding intervals. And T is your time in years. Right, so first we're just going to plug in, and our accumulated amount is $20,000 equals our principal, $12,500. You need parentheses here. 1 plus our rate, 5.75. Remember, take your decimal 2 places to the left. So 0.0575 over N is the compounding intervals. So this is 4. That means it compounds quarterly. Exponent is N times T. So it's going to have the 4 there. And the T is our unknown. So find the time in years. First, we will divide out the 12,500. We want to get this piece with the exponent by itself, without other pieces there. So we'll divide by 12,500. You will use your calculator, and I get 1.6 equals 1 plus 0.0575 4 to the 4t. Now we should clean up inside the parentheses. You want to make sure that you're doing order of operations here. If you don't want to use a couple of sets of parentheses, then just work out this piece that's in the fraction form first and add the 1. And that is what I did. So 0.0575 divided by 4 gives me 0.014375. And then I added that to 1. So I get 1.014375 to the 4t, and this side just comes down. And that's all we can do at this point. Now we want to get the exponent down, and this is where you take a logarithm of both sides. And you could do common log or natural log. I'm going to just do natural log. So I will do the ln of 1.6. And when I do the natural log on the right-hand side, it will bring the exponent down. That is why we're doing this. So I'm going to go ahead and put the exponent first, 4t times my ln of 1.014375. I did not round early. Right, now I want to isolate t. The 4 and this logarithm are just multiplied by the t. So I'm going to divide by it all in one shot. And that leaves just my t on the right-hand side. On the left-hand side, you will put this in a calculator. I'm very cautious as I put things in the calculator. So I'm going to use parentheses for the whole numerator and parentheses for the whole denominator. If you did not, I think when you get here, it would take your ln of 1.6 and divide it by 4 because it would do multiplication and division left to right. So parentheses are your friend. So I'm going to do parentheses for the numerator, natural log of 1.6, close the parentheses for the log, close the parentheses for the numerator, divided by parentheses for the whole denominator, 4 times, you can just go ahead and put the ln, or you could put the times, 1.014375, close the parentheses for the logarithm, close the parentheses for the denominator. Hit enter. So here's your answer. If they ask us for 2 decimal places, so the 3 is in the second decimal position or the 100th place. Look one to the right. This is not a 5 or higher, so this would drop off. So we're going to round to 8.23. For our next problem, they're giving us the formula for continuous compounding when you have the E in it. And so you will have to use natural log on this one. Our amount invested, 8,000, is your P. The interest rate, the R, is 8%. Remember, switch it to 0.08. And we want to double the amount. So we have to do just a little bit of work to find the accumulated amount. If we're going to double what we invested 8,000, this will be 16,000. So our A is 16,000. Equals RP 8,000. E rate 0.08 to the T. Our first step will be to divide out the 8,000. If you were very clever, you could have just put 2 on this side. Nothing wrong with the steps. And now we're ready to take a natural log on both sides because we want to get the T down. So I'll take the natural log on the left, so ln of 2. When I take the natural log on this side, it will bring this exponent down. So I'm going to go ahead and write the exponent first. Now, remember the ln of E is equal to 1, so we don't need that part. And all you have left to do is divide by 0.08. So we have the natural log of 2, so ln of 2, close the parentheses for the log, divided by 0.08, enter. So 8.664, and if we wanted to round to 2 decimal places, the second 6 is in your second decimal position, or the 100th place. You look to the right, and this is going to drop off. So 8.66 years. For this problem, we have a formula given to us, and it models the population of a U.S. state, A, so this will be the population, in millions, T years after 2000. So T is going to be our time. And so the first question is, what was the population of the state in 2000? Well, our T is after 2000. So if we wanted to be in the year 2000, our T would have to be 0. So we have A equals 15.7 e to the 0.0431 times 0, and anything times 0 is 0. E to the 0 is 1. So this piece is going to be our answer. So the A will be 15.7, and this is in millions. Part B asks, when will the population of the state reach 18.7 million? So this is the A in the same formula. And we need to find t. T is our only unknown there. It's in an exponent position, so we will take a natural log to bring it down. Before we do that, we have to get rid of this 15.7. So we're going to divide it on both sides. I rounded on this one to 1.191 equals, and I just brought this part down. Now you're ready to take the natural log of both sides so that this exponent will come down. So I have the natural log of 1.191 equals 0.0431t times the ln of e. The ln of e, remember, is 1, so that will just divide out. And then we're going to divide on both sides by 0.0431. And that will give us just our t. On the left-hand side, we will put this into a calculator. So we're going to do a natural log of 1.191, close parentheses for the log, divided by 0.0431, enter, and we get 4.05. We can round this up to 4.06 if we were going to 2 decimal places. You have to make sure that you answer the question that was asked. And on B, it says, when will the population of the state reach 18.7 million? They just wanted the year. So we'll just use the 4 here for years, and we need to add that to our 2000. So in the year 2004, that is when the population would reach 18.7 million.